we're going to continue on talking about disk and washer method. I have them both over here for you, just so we can reference them. So remember, a disk is when we do our solids of rotation and then we're slicing and we get circles as our cross sections. So it's just pi r squared. Washer is when we slice that and we get holes in them, so they look like little washers instead of disks. And to do that, it's still pi r squared. We have to take the outer radius squared minus the inner radius squared. Now, something I didn't mention in the last video is that these are both in terms of x, so dx, and that's if you have a horizontal axis of rotation, so if we're rotating this way. We can also have a vertical axis of rotation, and that means we'll have to be in terms of y. And we're going to see an example of that in number 3. So in example number 3, they want us to take the region bounded by y equals x squared plus 1, y equals 0, x equals 0, and x equals 1, and we were supposed to rotate that about the y-axis. So the picture is really, really important, okay? As you're doing your homework, please draw the picture. You're going to understand better what's going on. So this is a parabola that's shifted up one. Okay, so it looks like this. And then y equals 0 is here, x equals 0 is here, and x equals 1 is here. So we are going to take that region, okay, I'll shade that in for us. And this time we are going to rotate it around the y-axis. That is something different. We have not seen that yet. So this is going to come over here and look like this. And so it looks like a cylinder. Can you see that cylinder? Make that part a little darker. Okay, so you have the cylinder. And then it has a hole in part of it, but that hole doesn't go all the way down. Okay, so we want to think about slicing this into our circles. Our circles are going to go this direction. Okay, notice this time the width of your circle is in the y direction. So everything here is going to be dy. Also, it's a vertical axis of rotation, so that's why the change. Now, if you notice right here, if you're slicing down here, these are full circles, okay? That's a disk. So we need the disk method. But when you get up here, that's a washer, okay? That's only shaded here on the outside, and then it has this hole in the middle. So we're going to have to split this problem up and do part of it using disk method and part of it using the washer method. So to do that, first, let's talk about this section down here. This is going to be the disk part. So for the disk part, remember it's pi r squared. We are in terms of y. So our y values run from 0 to 1 here. And the radius of this, notice all of these circles have a radius of 1. Okay, these are all the same. This is just a solid thing. So we're just going to do 1 squared dy, and that's it. Plus, we're going to have to do the washer section up here, okay? So for the washer section, it's still pi r squared. Now we're going from our y values from 1 to 2. And we need to think about this washer. I've drawn one of them. Hopefully you can see I can make it a little bit darker for you. Okay, thinking about this one right here. We need to think about its outer radius and its inner radius, okay? Now, all of these have an outer radius of 1, okay, because it goes all the way out to here. All of them do. So our outer radius is going to be 1 squared minus our inner radius is here. And that inner radius is determined by the function, okay? So this function, that's this parabola, y equals x squared plus 1. But we're in dy. This whole problem is dy. So we're going to need to solve this for x, which is not a big problem. Then we'll take the square root of that. Okay. So this function is actually the square root of y minus 1. So that's what we'll put over here. All right. And so that's all set up, also going downhill, but we'll survive that. So on the disk part, we have from 0 to 1, this is just 1, so the antiderivative of 1 is y. I'm going to go ahead and finish this part while I'm here, and then we'll move on to that side. So that's going to be 1/2 y squared. I'm still a pi here. And we're evaluating that from 1 to 0. So we plug in 1 and we get 1/2. We plug in 0 and that doesn't matter. So this is going to be 1/2 pi. Okay. Now we still need to do the side with the washer. So we have 1 minus the square root and the square are going to cancel out. So this is just y minus 1. But be careful because that negative is going to get distributed there. So this becomes negative y and then 1 plus 1. So negative y plus 2. All right, and then that's what we're going to need to take the antiderivative of. Still got the pi out here. So we get negative 1/2 y squared plus 2y. I thought I was going to have enough room for all this. Now I'm doubting it. All right, let's see. Oh no, I made a mistake. Oh. Let's fix my mistake because I don't want to redo this whole video. Right here. This was 1. This was I took the antiderivative of this twice. That was wrong. My apologies. Well, I'm glad I saw that. Remember this was 1, so the antiderivative is just y. I should have plugged in 1 and 0 here. Okay, so we plug in 1, we get 1, and then 0, 0. So this is just pi, not half pi. Sorry about that. Okay, let's finish out over here. So that was just pi, and then when we plug in 2, let's see, we get negative 2, my work over here, negative 2 plus 4, which is going to be 2, then I'm going to plug in 1, so I'm going to get negative 1/2 plus 2, which is going to be 1 1/2, so 3/2. So this part, I think, is 1/2 pi. I'm going to double check that with the book because I've been known to make mistakes, as we can see. Yes, and then 1 pi plus 1/2 pi, our final answer is 3 pi over 2. Okay, sorry about that.